Okay, so I've given a presentation like this, actually, or one like this has been given for the past couple of years here and at multiple other venues like the Texas Hot Mix Association, the chip seal binder seminars, and like. So I'm going to try to hit some of this really fast because my goal is to talk mostly about not what the research is doing. That's already pretty much done. I want to know, I want to talk to you about why you should be interested in adopting this. So I do have some slides that say what's the motivation and objective and to describe the spec and the work plan, and then talk about the end of the world. So the main objective of this whole work is to increase the performance and reduce the cost for seal coats. I think nobody can argue with that. Lots of seal coat stuff is kind of art and less science, but the binders have a lot to do with performance. So we might as well do the best that we can on the binders and the best that we can on the aggregate. So we wanted to improve the chip seal binder specification by using performance-related tests, use temperature regimes for those tests that simulate the climate that it has to perform in, just like PG binders. So I want to make sure that everybody understands the distinction. This is not PG binders, this is SPG binders, surface performance grade binders, because we're looking at what's going on at the surface. This is an implementation project in a staged effect, which is in its second to 2.5 years. So just a little bit of history. This is the historical development of specifications for hot mix. The yellow dots is what our specification required in 1962. It required penetration. It was a penetration-based specification with minimums and maximums at one temperature, and that's 25 C, which is probably only one time does that. The pavements see that. We don't look at any other temperature. We didn't look at any other temperature regimes. In 1972, we added the X's, and that gave us a little bit more control over what the binder was doing with changes in temperature. We looked at things like the high temperature properties for application, and we also added some viscosity. This is high pavement temperature. That's okay, but we're still stuck with intermediate temperature, which doesn't mean a whole lot, and nothing at all at the low temperature. In 1997, we implemented the PG binder specification for hot mix. And then we added some other stuff. We added this stuff down here, and each of these lines represents an age state. So this is original binder, thin film oven aging, and this is long-term pressure aging vessel. So we described the climate it has to perform in and the age state at which it has to perform in with the PG binder system. So chip seal binders in 1962 with the yellow dots, penetration graded, one point. And one of the things you learn in any mathematics course like geometry class is 1 point does not determine a line. So you got 1 point in time. It's 1 point, it doesn't tell you much. So in 1972, we added the X's, similar to what we did in hot mix, except we didn't do anything else. We stopped there. Now there's a few binders that have a few other additional tests. We actually added a few of the PG type tests to a few of the binders, but not all of them, only some select. This is the historical development of emulsion chip seal binder specification, and you can see it's arrested development. We have not changed significantly, except for a few of the polymer modified binders. We have not changed significantly since 1962. So we're 50 years behind the times or more. It's time to do something about it. So this project started off with research projects. This implementation project is culminating research projects that started taking place in soon after we initiated the PG binder system in 1997. In the early 2000s, we started doing some of this work, and we've been doing work ever since. This is just shows a little example of what we're looking at. This is a kind of a mock-up of a specification, and the main thing is we're running dynamic shear rheometer on the original binder in an unaged position condition, because that's like what it's going to be like when it's sprayed onto the ground or onto the pavement. And then we're running bending beam rheometer on an aged material, and that's what it's going to be. It's going to get stiffer and stiffer as it ages, and we want to prevent, number one, loss of rock early on by being not stiff enough, and we want to prevent loss of rock later on when it's too stiff and the binder fractures and the rock is lost. So this is just a little bit more of the description of the specifications based on same type of temperatures as PG binders, except a little bit different because the definition of the temperatures in terms of where they're taken. For hot mix PG binders, the temperature that you specify on, like PG 64 minus 22, that 64 degrees C is based on 20 millimeters below the surface. For a SPG, we're looking at the surface. We don't have any 20 millimeters below the surface, so we're looking at surface temperatures. This is just some more, a closer look at the specification. So we have written, and we have out there posted on the internet some specifications that allow it has the specifications developed by the research in them for use on TxDOT projects if so chosen. We have a specification written for the 2004 specification book, and that is Special Provision 300-054. And we have another one written for the 2014 specification book, which is 300-001. They are identical except for the format. This is a copy out of that specification, and you can see if I want a binder. It looks very much like the PG binder specification in the book. I choose a high temperature and I choose a low temperature and meet the specification down the line. The one difference right now is that we have 3-degree increments, not 6. I'm not sure that that's, in this implementation process, we're open to changing stuff and modifying this stuff as we go so we get things right. So right now we're looking at 3-degree increments, not 6. We don't know whether that's going to survive or not. Right now we're still looking at 3. This is the part of the special provision on emulsions. And an emulsion is an emulsion is an emulsion. An emulsion has emulsion properties, and then it's got the residue properties. When that historical development that I talked to you about on chip seal binders and emulsion binders, that was the residue properties. The emulsion properties are still the same. You got cationic, you got anionic, you have demulsibility, you have separation, all these different things that are describing the emulsion. Those don't change at all. So we have, for instance, an HFRS2, and this scenario wouldn't have HFRS2P. We would have HFRS2 SPG X-Y, X and Y being to the SPG temperature grade that we choose. So we could have an HFRS2 SPG 70-19, for instance. The HFRS2 emulsion properties are spelled out exactly shown here. The residue properties meet the table that I showed you last slide on the SPG properties. So the work plan on implementation has been one of shadow spec, test products that are meeting the current spec, making sure the industry is involved and understands where we are, making presentations like this so everybody understands where we are and hopefully where we're going. One of the other things associated with this spec is how do you choose material, and so we're working on looking at a climate-based solution just like PG binders. We've developed some maps, and we've been looking at things like maybe there are reasons that somebody would want to bump up the high temperature properties, maybe even bump down the low temperature properties to get a binder that would fit your needs based on climate, and then changes based on things like traffic levels and loading levels and speeds and things like that. Here is an example of one of the maps. This is at a 98% confidence level, and you can see that this shows 6 different colors. We've already determined that the orange color down here, orangish red color, we're going to say it goes away and gets incorporated into this. We do not have any material being supplied that is as bad, low performing as a -10. Consequently, we're not going to specify that. So essentially all of this reddish color gets incorporated into the orange color. And you can see there's a wide range of performance properties. In the extreme panhandle, we've got going down to -25. But for the most part, we're talking about -16, -13 through the center of Texas. So the other thing is that if a supplier were trying to sell a binder, they would look at this map and say, oh, you got too many, you got too many grades here. We don't want to have 5 different tanks. And the answer is you don't have to have 5 different tanks because you're not going to supply the whole state. And that narrows it down. Plus, you can always give us a better performing binder than what we asked for. So if a supplier said, I can make this product right here, they could supply it anywhere south of here on the climate-based grade only. That doesn't mean, excuse me, that doesn't mean that we wouldn't bump up the temperature or bump it down to address traffic. So what we've been doing is we've been taking samples for the past 2 years. The 2013 season and 2014 season, we're taking samples off of existing projects. Those projects were bid with binders like CRS2P, AC15P, AC25TR, AC20XP, those materials that are in our current specifications, so we've been grading them according to this SPG specification. The next step is to try to actually buy some of these products. We've got one district that has committed to an RMC seal coat, not a district-wide seal coat, but an RMC seal coat where they have selected a PG 70-19 with a construction division's input that will be let, I think, in the November letting for next year's, part of next year's season. So what are we doing with this stuff? Well, let me back up. We want some more projects, at least one more project that is decent enough size that people will be interested in it. So we got one. Corpus Christi District would be interested in. Part of why I'm up here is try to sell this thing, because we've done a lot of work on it, a lot of investment. We think it can pay off, but at some point you gotta domino. You gotta do something about it. So I said that we're available to change this throughout time as we see fit, because we're trying to step into this thing. We'll look at the 3-degree increments. We'll look at anything in the specification that isn't really telling us anything. We may eliminate that. We also added one thing to help people to ensure that they get polymer modifiers. That's one thing that we like. TxDOT likes is polymer modifiers, and we've added a phase angle requirement for any binder that has a temperature range of 89 degrees or more. This is a summary of some of the binders that were acquired and tested in the summer of 2013. Actually, no, this is before 2013. This was done through the research project, and some we got in 2012. On the left, you see this is what the material was bid under. This is the specs it was supplied under. And these are, and there was multiple samples of these. These are the grades that they met. So I'm showing you this to show you that our current specifications are very wide open, and that I can get a lot of variability in the performance that they give me. And if I went to the SPG spec, I may be wanting one of these, I don't want you to give me these. I want you to give me maybe this one in Amarillo. Or actually, I may want something else. In Amarillo, I may want a minus 25. So in the 2013 season, we got some more samples. This is a map showing what those are. You can see we got quite a few samples around the state of various products. These are what the grades were for those things, and then I summarized them in this so you wouldn't have to figure this out. Same type of summary. These are the materials that were shot. They were purchased under these specs, and these are the materials they met. So again, we see more variability in what we're getting with the new specific. If we graded by SPG spec, what we're currently getting, we are getting high variability. And high variability probably means that you don't know what you're getting. It meets the current spec. Every one of these met these specs, but these specs are wide enough that it allows you to meet multiple SPG grades. So what are we going to do? We want to do some field trials where we're actually bidding material. We're going to see whether we need to make any modifications to the spec for future years. Ultimately, the goal is that the chip seal binder spec will be supplanted by this. Eventually, TTI will make an economic analysis of this too. However, when we went into this implementation project, we had to do some economic justification to get it funded. As it turns out, if you can say, you know, if I change the binder spec such that on only 20% of the lane miles that we do annually, I can get one more year of life out of it. Seems like a modest request. I can save $9 million a year. $9 million a year. We do $200 to $300 million worth of chip seals a year. Okay, so I need to answer some questions. I told you I'm trying to sell this thing. So how do I get my polymer? Well, I alluded to it that we've got this rule of 89. If you look at the specification, if the difference in the high and the low temperature is 89 degrees or more, there's a phase angle requirement, which means there's an elastic property to that binder. How would I call for material using the spec? Well, these are some possible grades. I could call for SPG 73 minus 25. I could also call for the emulsion equivalent to that, which would be a CRS2 SPG 73 minus 25. Likewise, I could call for these other various grades with their corresponding emulsion equivalent. Okay, so now I'm coming to a little bit more selling. So the question, and my last bullet on my intro was I'm talking about the end of the world. So like the REM song, is it the end of the world as we know it? So I'm going to tell you no, and I'm going to tell you why. If we implement this, we're going to select our binders based on climate. We wouldn't expect the same binder to work as well in the valley as in Amarillo. But right now, we use the same spec in the valley and in Amarillo. It doesn't make sense. We don't use that for PG binders. It only makes sense that the same thing holds for chip seal binders. We can modify the grade based on traffic or other considerations. So you start off with what my climate is. Is that sufficient? If it's not sufficient, like for instance, I have a high ADT or I got a lot of trucks, I may want to change that. If I have a more flexible pavement structure, I may want to do a bump down on the low temperature side. So there's flexibility with the district in selecting the binder, and a person could select the binder such that they will get an elastomeric additive in the binder because of the phase angle requirement. We could also, if we wanted to, we could say, I'm going to set emulsion and hot applied equally. They could be alternates because the residue would have to meet the same residue as a hot applied binder. So what we learned in the PG binder system when we implemented that in 1997, we did a similar type of thing. We got everybody's AC20s and AC45Ps and we graded them, and we saw some of the same type things. We saw AC20 around the state met like 3 different grades. Well, that means that we implement PG binder system for hot mix, we got a more consistent product. But every person's binder, everybody's binder will meet a grade. It's just a different name. It just may not be the one that you need in your area. So the SPG is a tighter spec and we'll get less variability because we're asking for a specific cut out of what we've been getting, not the whole wide range that it could meet. Current higher performing binders will still be current higher performing binders. I showed you AC25TR. It met some of the higher performing binder requirements. Asphalt rubber did too, and so did AC15P and AC20XP. Although we're not going to be constrained to those specifications. We're asking for performance, get it the way you need to, which might mean, we might see some different types of products, different types of additives possibly, but more like different types of products that are tailored specifically to that PG or SPG grade. They may have to add more polymer, or they could get away with less polymer, but they will control their process more. Now, the other thing is the tiered system. We've been under the tiered system for several years where I got tier 1, tier 2, tier 3, and there are specific binders that are available under that tier system. Some of them, like tier 1 has no emulsions. Tier 2 has polymer modified emulsions and polymer modified materials. Tier 3 has pretty much unmodified materials, and we have done a kind of a progression such that currently very little tier 3 is being used. If I specified my binder based on the SPG, I may have a tiered system to look at what my bump ups or bump downs might be, but otherwise the tiered system as we know it does go away. So this is one system, one thing where this might be the end of the world as we know it for the tiered system. But remember the end of the line. It's the end of the world as we know it, and I feel fine. So I think it will be good. I think it will be an improvement, and I think we can come out of this doing better than what we're doing now. So again, the research has been done. There's some little tweaks that could be made between now and some future date. Right now it's like we got to start doing this, and so I'd be happy to entertain any questions, or if anybody wants to come up to me afterwards and volunteer, I'll be happy to hear that too. Thank you.